Hello, in this video I am going to cover, are variable sizes the same on all computers? So you might be thinking a variable is a variable, like an integer for example, it's just an integer. But it actually isn't necessarily going to be the same size. So I've got a website open here, and it is the Wikipedia page for integer computer science. And generally speaking, an integer is 4 bytes. So if we scroll down, if we go to, I'll provide a link to this in the description. Short integer, they are saying in all these languages is the same. Okay, that's pretty simple. Let's go to a long integer, and the description is a long integer can represent a whole integer whose range is greater than or equal to that of a standard integer on the same machine. So it's basically saying a long integer can be the same size as a regular integer or longer. And if you had watched the video where I covered integers and long integers, you would have seen that, that's what was the case for me. A long integer on my machine was actually the same size, in certain, circumstances. So if we scroll down, on the C and C99 standard with these platforms, so Unix 1632-bit and Windows 1632 and 64-bit, a integer has a minimum of 4 bytes, which, let's just look at unsigned for now, is 0 to roughly 4 billion. Whereas if on the same standard you are on a Unix 64-bit machine, it has a minimum, it has storage in 8 bytes, still a minimum requirement of 4, but they're usually 8, which means this is a big number. This is 1,000, million, billion, trillion, quadrillion, quintillion, I think it is, quintillion. So it's essentially 18 million, 0 to 18 million. It is significantly larger, even though it is still just a long integer. If you are on the C++ ISO ANSI standard and you are on Unix, Windows 16 or 32-bit system, it is 0 to roughly 4 billion. Same for the C++ CLI. For VB, so that's the VB programming language, there isn't an unsigned range for some reason. Did not know that. And SQL Server, it is similar, 8 bytes as well. So that's, it's just something to bear in mind. I just wanted to cover that not on all systems will the data type react the same way. For the most part, you can use an integer as an integer, and because your numbers probably won't be going that big, you probably won't be having any issues. But that's just something to bear in mind. If on one system it works, then on another system, let's say some of the numbers don't quite work the way you want them to, maybe check the CPU architecture. What sort of, programming language, standard has been implemented as well. That's the reason when you see some code online, especially to do with game development, in the realms of like OpenGL, for example, you'll see special types of integers. And you'll see something like a GL int or a GLU int for an unsigned int. And you'll even get ones where, I know SFML have their own underlying integer system, etc. So what these do, they just standardize it. So on all systems that particular library, framework, or standard like OpenGL is running on, the integer will run the same way. Underneath, it might be programmed differently, but it will actually run the same way. So that's just something to bear in mind. That's the reason sometimes, especially with OpenGL, you'll see stuff like GLint. It's very important when you're, especially with OpenGL, you're interacting with low-level hardware like the graphics card. You don't want discrepancies that can cause all sorts of issues. So that's it. Are variables the same size on all computers? Not necessarily. So just something to, have in the back of your head. Thanks for watching. If you have any questions, feel free to post on the Discord group. There's a link in the description. There's over 4,200 members now. A bunch of programming channels. There's a link to the GitHub page for this course as well in the description. And as usual, I look forward to seeing you in the next video.